Okay, so let us start the test portion here. This starts the test portion, means the numerical portions for chapter 3, atoms and molecules. Now in the previous video we discussed this formula. Now we have to be very clear about this formula, because 70 to 80% of the numericals in this chapter are going to be based on this formula here at the top. Okay, let us start with the first question, test 3D here. The first numerical test in this chapter, 3.1. It's quite easy if you just follow carefully and remember this formula especially. Now the first question here, 3.1, is on page 41. So let us go there and see. On page 41, let me read the question. Example 3.1a, calculate the relative molecular mass of water. So let us do that. So here, A, the first question, is put as a subheading of small a. So here, relative molecular, okay, just do slowly, okay, relative molecular mass of water, let us say, very common substance. Even the formula is given in the question itself for us, but even if they did not give, water is a simple formula, right? All of us know it is H2O. Now here you see, before we go there, I want to explain one thing which is quite important. Suppose we have here 2 O2. Now here this is 2 oxygen molecules. So here, if you have here at the back here, the number of back one is called subscript. Subscript means the small letter, small size. The one is called in front is called main script, so it's slightly always written bigger to the back one. Now the number of atoms will be given by the subscript. What I mean to say is that number of hydrogen atom in water is not given in the front but in the actually in the back. Okay, so there will be 2 hydrogen atom, and then by that I also mean that at the back of O there is no number, means 1 oxygen atom, meaning we are trying to say that 2 doesn't belong to O, because 2 is the subscript of H, not the subscript of O. So the number of atoms you always search from the back of the symbol of the atom, H. How many H atom? Hydrogen atom at the back, 2. So there are 2 hydrogen atoms in water, so we write that 2 and then put multiplication sign into, go to page 37 of your text. There is a table of atomic masses, and we know that hydrogen, 1 hydrogen is 1U. So 2 into 1, because there are 2 hydrogen atoms. And then when you go to a new atom, you always put a plus sign, okay? Then go to O. Now, how many O is there? As I said, don't search front here, back side. So at the back, no number means 1. So there is 1 oxygen atom, and page 37 tells us that 1 oxygen atom is 16U. So you just put your U, and 2 ones are 2, plus 1 into 16. So that will be equal to molecular mass of water is 18U. That's your answer. At B, I think we have to find here, as you read the question, it says, calculate the molecular mass of HNO3. So same type of question, molecular mass of HNO3 this time, which is called nitric acid, okay? So at the back of H, you search how many hydrogen atom? No number means 1 into hydrogen is 1, as we have learned on page 37, and at the back of N, only no numbers, so 1. 1 nitrogen atom weighs 14U on page 37 you will find. And I'm going to a new atom oxygen, that's why we put a plus sign. So after each new atom, you're done with that, and put a plus sign. Then at the back of O3 means there are 3 oxygen atoms in nitric acid. So multiply the 1 oxygen weighs 16U, so we put there 16, and you put here, instead of putting here and there, put a bracket and put a common unit U. Okay, so that is 1 ones are 1 plus 14, 1 into 14, and 3 into 16 is 48. So I think this is not complicated, so let's just add directly 40, 50, 62, 63. So molecular mass of nitric acid is 63U. Okay, now 3.1 is done, so let us go to 3.2 here. Okay, example 3.2. I think it's on page 42, so let me read it. Calculate the formula unit mass of CaCl2. So just write the answer here. Formula unit mass of CaCl2. So CaCl2 simply means calcium chloride. Okay. Now, how many calcium atoms? This Ca is the symbol for calcium atom. Cl is chlorine atom. So there are two atoms. I mean, two types. There are three atoms, 2 plus 1, but two types. So at the back of Ca, no number means one calcium atom. Into page 37, you go, you see that one calcium atom weighs 40U. And you go to new atom, so we put plus sign. And at the back of Cl2 means, what does that mean? Yes, there are two chlorine atoms. At the back of Cl, there are two means there are two chlorine atoms. So you write here two chlorine atoms, and one chlorine atom weighs 35.5. You go and check page 37, you will find that. So common unit U. Now this will be 40, and when you multiply this 35.5 to 2, 2 5s are 10, then 2 5s are 10 plus 1 11, 2 3s are 6, 7. So 71, and one decimal means point here, so 71.0, which means simply it is 71, right? So this is, as you add, you will get 111U, right? So that is the formula unit mass. So we understand that formula unit mass means the same thing as molecular mass. It's just meant for ionic substances like calcium chloride. Otherwise, the calculation is the same meaning as molecular mass, okay? So we're done with 3.2 also. So let's go to 3.3. Just follow it slowly and carefully, okay? And then if you're confused, you replay the videos and listen carefully to them. I think you will get it without much problem. So example 3.3, let us say, okay? Now, here page 43, look there. Calculate the number of moles for the following. Number 1, 52 gram of helium. So number 1, we're going to do this one. So in the bracket, it's given finding mole from mass. So you have to use this mole formula. So we're going to start to use this formula. As I said, most of the numericals are based on this formula. They are not at all difficult, okay? Just listen carefully and then replay the videos as I said, if you're getting confused. And once you get it, it's quite easy, okay? So bracket says find mole from mass. So you have to use this two portion of the formula. So when we know this formula, in almost most of the sums, we'll be using two parts. This one, mole and mass, or mass, and this is called number of atoms, so number and mole. So you will be using only two at a time. Read the question and you'll know which one to use. Find mole from mass means we have to use this mole from mass. You have to find the mole. So what you want, the question is saying find mole means we want to put on right side, right? So here you can start with that. We know means we mean to say we know this formula, mole from mass. So you want to put mole on the right side. So gram, see here, gram, and see whether it's atom or molecule. 52 gram of He, like that only they have given. They did not tell us whether it's atom or molecule, but it's easy here. The trick to find is here, gram. I will write there it's atom, okay, and we will explain why it's atom. Atomic mass of He. He means helium, the symbol for helium element. Now, how do we come to know that we should put atomic and not molecular? The trick is from here. At the back of helium symbol He, what is the number? Yes, 1. So when it is only one atom, we always write atomic mass. Let me settle this once more so it becomes clear to you. Suppose you have here 2. That means there is 2 oxygen atoms connected by bonds. Now, more than one atom, so we'll call this one as molecule. But if you have only like this, then we'll call this one as atom. Then how about this one, Na2O? How many atoms are here? At the back of Na means 2 sodium atom, and here 1 oxygen atom, so total 3. So more than one atom, so definitely molecule. Simply put, more than one atom Same type or different type, more than one atom is molecule, definitely, and one atom is atom. So here no number means only one type of atom, no number means one atom only. So that's why we wrote atomic mass. Okay, will be equal to, according to this formula, gram atomic mass always equal to 1 mole. As I said, as we're using this mole and mass because the question told you find the mole from using mass. So we're going to use this gram mass to find the mole. That's what the question is saying. Now here, just follow this one. Now that is, in other words, here you can extend this bracket slightly, so you can calculate from here itself the gram atomic mass of helium. Here see, at the back 1 means, that is, we mean to say 1 into 1 helium atom. On your textbook it's not given on the page 37, but just know this, okay? 1 helium atom weighs 4 grams, so only 1 atom of 1 into 4 is 4 gram is the gram atomic mass of helium. So this 4 gram, in other words, contains 1 mole or makes 1 mole. Okay, then we're going to follow this mango method. Let us say 4 mangoes are there and it costs us rupees 40. Simple number, okay? Then how much do you think will 1 mango cost? Don't calculate, just common sense. Yes? Yes, that's right, 10. How do you get that? This 40 you divide by this 4, right? Then we get that 10, you just say it now. So that is how you get. Similarly here, 4 grams, 1 mole, just like 4 mangoes, 40 rupees. Therefore, what would you say? 1 gram of helium will make how many mole? Well, 4 mango, 40 rupees. So 1 mango, 40. This divided by this. So we also do the same thing. 1 divided by this 4. Just like we did 40 by 4. 1 by 4 here. This side, left side by right side. Right side by left side. Right side by left side. 1 by 4. And then the unit on right side is mole. So we write there mole, right? Now, but the question is asking for not 1 gram, 52. So, but why did we get for 1 gram? Because if you get for 1 gram, you can get anything after that. That's why. So it helps us to find 52 gram of helium. That's what the question is asking. So just like you did for mango here, if you want to find the price of 8 mangoes, then how much is the cost? Common sense. Yes, 80 rupees. How do you get that? Price of 1 mango, rupees 10, multiplied to number of mangoes here. This multiplied to this, and you get that 80 rupees. Similarly, for 52, multiply this right side, 1 by 4 mole, just keep same, multiplied to the left side, right side of the previous step by left side of the same step, that is 52. Just like you did here, right by left, up and down, up and down, up, right, left, down. Same mango method we're using, right? So 4 ones are 4, it's going. Then 4 ones are 4, but 5 is there, so 1 remainder. That 1 will go in front of 2. If 1 go left side or front of 2 means 12, right? So 4 threes are 12. So your answer for this first question is 13 moles. So this is 52 grams of helium will contain 13 moles. Okay, I hope you're getting it. So now we have calculated the mole by using the gram mass. That's what the question told us. Find the mole by mass. Okay, now let us go to 3.3, number 1, and subheading Roman letter 2. I hope you're getting it. Now, let us see there. Calculate the number of moles for the following. Number 2 is different. 12.044 into 10 to the power 23 number of helium atoms. Still atoms, but this time the method is different. Find the mole from number. Previous one was find the mole from mass. So we use this one, mole and mass. This time, find the mole from number. So you have to find this mole by using this number of atoms. So we should not use this mass this time. Okay, so now find the mole means what you want to find, we want to put on right side usually, right? So though it's not a hard and fast rule there. So here we know means, as I said, we know this formula. Find the mole from number this time. So we know that Avogadro number 6.022 into 10 to the power 23, and we can use the same language of the text. Number of helium atoms. They are saying like that. So number of helium, okay, He atoms. This time they mentioned, even if mentioned that it is atoms even. But even if they didn't mention, we know it's atom. No number at the back means atoms. This one always makes how many mole? Equal to 1 mole of helium, that means. So we know, means this formula we use this and this. That's why we're saying we know, because it's in our memory. Right, so here, again mango method. So let us find out for one, so many atoms, 1 mole. So how about 1 atom? 1 number of helium atom. 1 number of helium atom. Just like you did for 1 mango, left by right, oh sorry, right by left, right by left again. So right is 1 divided by left here, 6.022 into 10 to the power 23, and whatever you need on the right, we'll write that. Not this atoms, we write that right unit, okay? Left unit on the left, right unit on the right always. So if you found for 1, you can calculate for any. So that's why we found for 1 atom. So our question is saying find it out for 12.044, yeah, 44 into 10 to the power 23 number of helium atoms. Then how many mole will be there? Question is saying. So like we did here, right and left. So here also right and left again. So 1 divided by 6.022. Mango method only, okay, quite simple. Get confused, then go to the mangoes again. You will get it very easily, 10 to the power. So we don't need any formula if you know this one and the mango method. Every of the numerical is like that. Mole, you can write right and left. So left there, left down. So that is 12.044 into 10 to the power 23. Do it slowly by thinking, then it's easy. 10 to the power 23 down and up will cancel. Then here, just notice this 6.022 into 1 is 6.022. Then let us write 6.022 into 2, multiply on the rough. You'll find out that this is 2 2s are 4, 2 2s are 4, 0 to 6 are 12. Then 1, 2, 3, 1, 2, and 3. So into 2 is going with this one, 12.044. So our answer will be, here 2 is left, 2 here nothing, here 1, so 2 1s are 2 moles. 12.044 into 10 to the power 23 helium atoms make 2 moles, the answer. Okay, so 3.3 done. The final question, 3.4. We'll do slowly. It's quite easy. Everything is, just know this formula, read the question carefully, and every question of this type will be like, you have to find the mole from mass, or mass from number, or the number from mole. If you read question carefully, you will know which 2 to use. And then remember the mango method. And any sum that comes, you'll be able to do, okay? So let us try the next one. Example 3.4, right? 3.3 is done just now. Page number 44. Okay, let me read the question. Calculate the mass of the following. So you have to calculate mass in every question there. 3.4 subheading number 1, let us say. As I said, keep the formula and the mango. Read the question first. Let us do. Calculate the mass, number 1, 0.5 mole of N2 gas. Calculate mass from mole. You have to find mass from mole. So this one and this one. So we shouldn't be using this one. So as you read question carefully, you will know this which 2 to use. Calculate mole, mass from mole. So you want to find mass, want to put on the right hand side maybe. So here, even though that's not a hard and fast rule. So here, 1 mole of, then you go to question and use the language of the text, 1 mole of N2 gas. The question says that, so just write here, N2 gas. We have to use this 2, right? Is equal to what? It's gram, very clearly gram, Now the problem is atom or molecule. Look at the formula, you'll get the answer. They didn't mention. So wherever they have not mentioned, at the back of the symbol of atom, what is the number? 2. Yeah, anything more than 1 is molecule. So just write there confidently, molecular mass. It's gram molecular mass means simply molecular mass of N2. So what will that be? Here at the back of N is 2 means 2 nitrogen atoms make the gas. Multiplied to page 37, 1 nitrogen is 14. Because they're saying gram, we put here gram. So that is equal to 28 grams. Now they are asking for not 1, go to text, 0.5. So you write here 0.5 mole of N2 gas, therefore will be, just write whatever is there, mango method again, into this, right to left, right, just like 10 to this, 1 mango already there, 1 mole already there, into 0.5, this number. Now just remember this, that 0.5 means half. Naga means if you say ada, so 0.5 into 2 kurle, 2 la ada, take half ki mana se? 1. Yes, that's correct. 0.5 into 6, half of 6? Yes, 3. So 0.5 into 28 means half of 28 will be 14 grams is your answer. Okay. Now compare this to the next one, subheading 2, you will clearly get the difference between gram atomic and gram molecular mass. No more confusion, then you'll have no problem. Okay, number 2. Calculate the mass of 0.5 mole of N atoms. This time they even mention atoms. So here, okay, then bracket is saying mass from mole. So same as previous one. This also mass from mole. Mass from mole. This also mass from mole. So let us put mole this side, left side. 1 mole of, and go to text and use the same language. 1 mole of N atoms. N atoms will be equal to what? It's, because we have to use mass, gram molecule or atom. At the back, no number. So this time they've even mentioned it atom. Even if they didn't mention, we can easily find out gram atomic mass, because at the back no number means atom. At the back more than 1, 2 here is molecular. So please get the difference now. So that is at the back no number means 1 atom is there, and 1 nitrogen is 14 grams, as you can see here also, which we got from page 37 of the textbook. So that is equal to 14 grams. They're asking for 0.5 mole. So 0.5 mole of, okay, 0.5 mole, you may not repeat writing, N atoms will be equal to whatever number you got there, 14 grams multiplied to 0.5, right and left down. Right 1 mango, right 10, left down 8. 1 mole is there, so right and left down. Mango method, right? So 0.5 means half, so 7 grams, because half of 14. No need to go to rough also, if you know this, that 0.5 is half. Okay, now let us go to the third one, the last second one, this portion. So the third one is saying, let us say mass of 3.011 into 10 to the power 23 number of N atoms. This time you have to find the mass from number, bracket, see the bracket, mass from number. Means you have to get this mass by using this number of atoms. We should not use mole now. So here, you write here, this one, no, this one. 6 we know, means from the formula we know that 6.022 into 10 to the power 23 atoms or molecules, let us check, clearly mention number of N atoms. So just write the same language. Number of N atoms according to question language. This is the language. This one is not from the question, this is from the formula here. See, will be equal to always the mass means it's gram, and very clearly at the back no number, and even the question says atom, so gram atomic mass is gram atomic mass means gram atomic mass of N nitrogen. So that is only 1 at the back, no number, so into 14. So that is 14 grams is the gram atomic mass of N. The question is saying, what is the mass of, let's just find out for 1 first, like mango method. 1 number of, okay, 1 number let's keep in the same place, of n atom. One number of n atom will be equal to, as we said, mango method, this right by left. So right is 14 divided by left is 6.022 into 10 to the power 23. This one, this many grams. So next here, we can write down, therefore question is saying for 3.011. So you write there 3.011 into 10 to the power 23 number of n atoms. How much will be the mass? Just like mango method, right and left down. Right here up, previous step 6.022 into 10 to the power 23, same right side is gram, multiplied to this one here 3.011. so right there 3.011 into 10 to the power 23, and this right unit is gram, so we should not bring this atom on the right side. Okay, now this 10 to the power 23 and this 10 to the power 23 cancel. 3.011 into 1, 3.011. Let's try 3.011 into 2 on a rough. 2 ones are 2, 2 ones are 2, 0, 2 threes are 6. So here 3 decimal places, so count from the extreme right. So here 1, 2, 3, so 6.0 exactly going so into 2. Then 2 ones are 2, 2 sevens are 14. So the answer is 7 grams. One more question, okay? 3.4, subheading number 4. Number 4, subheading. Let's read the question. Okay, so calculate the mass of 6.022 into 10 to the power 23 number of N2 molecules. Even they mention molecules. You have to calculate the mass from number. Mass from number. Same method. These two ticks. So here we clearly know from the formula that 6.022 into 10 to the power 23 of anything. Okay, so guessing numbers, so that one language you can get from the question. Number of N2 molecules. They even mentioned molecules, but even if the question did not mention molecule, it's easy to figure out here. The back 2 means molecule, we know that will be equal to number from mass from number. So it's right here, it's gram, very clearly molecule, so molecular mass of that of this one N2. So 2 atoms, so 2 into 14 grams, which is equal to 28 grams. So the question is exactly saying that find the mass of 6.022 into 10 to the power 23 number of N2 molecules. So Avogadro number only they gave, so that is the answer, 28 grams. So that concludes this test 3D portion. Now all the questions in the 3D question paper will be identical. I would say very identical, word for word also identical. Only thing is number will be slightly changed. Here 6.022, there it may be 3.011 into 10 to the power 23. Even this will be similar. It's not hard. So take the note on which you have written the sums just now with this video, and then compare it with that test question, and it's more like practice. So don't miss your test, okay? You will really improve if you do that. I guarantee you, okay? Okay, so that's it.